certain motor is able to pull a 20-kilogram block across a frictionless floor, increasing its speed from 10 meters per second to 12 meters per second in 4 seconds, at what rate is work done? So we know power equals the rate at which work is done, and power is equal to work over time. But in this case, work equals the change in kinetic energy because there's always kinetic energy present. So the formula for kinetic energy is equal to 1/2 mv squared. So initially, so the mass stays the same throughout. So the mass is just 20 and 1/2. And the initial velocity was 10. And then they said that it changed to 12 after. So if we do 20 times 12 squared, kinetic energy is equal to 1/2 times 20, 100, minus 1/2 times 144 times 20. Plug this into my calculator, and that it equals negative 440 because I calculated the change in kinetic energy wrong and I was too lazy to fix it. It's supposed to be change in kinetic energy is equal to KEF minus KEI. So it would technically be positive 440. And then so that means we have our work. And we divide it by our time, which was 4. And then that is equal to 110. And the unit for power is watts. So our next question says, a ball is tied to a string and swung in a horizontal circular path at a constant speed. The tension force acting on the ball is 20 newtons and the circumference of the circular path is 4 meters. How much work does the tension force do on the ball during one half cycle of its motion? So work is equal to force times distance, and it's parallel to like the object's motion. Parallel. I cannot write. So the net force for like circular motion is always pointed towards the center. And so there would end up being no work done because like it would always be perpendicular to the object's motion, because let's say like the ball was here, the net force would be pointed there, and work is like parallel to the object's motion. So but here it's like perpendicular, and if you do like cos of 90, you'd get 0. So that also shows that like there would be no work done. Let's just say you had a force applied to the right and the object moved to the right. You would be able to, you'd have work here because cos of 2 pi is equal to 1. And in the other scenario was perpendicular. So and cos of 90 equals 0. So just no work in the other scenario. Like, you'd never have work because it would always be perpendicular to the object's motion, because the object's moving tangential, and it's just the net force is always pointed to the center at any point in its like path.